Here's another application problem. I want to emphasize that this is not a question similar to one that you'd find in the homework. All of these problems have the common element of you draw a triangle, or maybe multiple triangles, and use trigonometry to find some missing side or missing measurement. Sometimes you need to use the triangles in creative ways. Like there's a problem in the homework about an angle of elevation and an angle of depression. And so you're looking out and you have to find the height of a building or something given the angle of elevation and the angle of depression. You want to find both of those side lengths and add them together. There isn't a one step solves the whole thing at this point. For this particular problem, we also have to be a little creative in order to answer it. Find the distance diagonally across a regular hexagon, so a six-sided regular shape, and the distance from one parallel face to another, giving the length of a side is 2.15 centimeters. In other words, we want to find x and we want to find y. At this point, though, we only have two pieces of information about this triangle. We know that the angle is a right angle, and we know that one of the side lengths is 2.15 centimeters. We need more information. I'm interested in finding some of the angles. We obviously can't immediately find the side lengths, but I think we can find the angles. Because if we think about this regular hexagon divided into triangles, I know if we think about the top angles of all 6 of these triangles, those top angles together form 360 degrees. They form a circle. And so if there's 6 of them at 360 degrees, so 6 times this angle x is 360 degrees, that means each one of those angles is 60 degrees. So if each one of these angles is 60 degrees, I can look at this triangle and I know that the sum of these other 2 angles have to be 120. And I got that because I know that these angles have to be the same size since this is a regular hexagon. So 60 plus 2 times, let's call it angle theta, equals 180 degrees. Solve that for angle theta, and that is an angle, not a 0. And we should end up with theta equals 60. Each one of these angles is 60 degrees. What that tells us is that, going back to our angle drawing here, this angle right there also has to be 60 degrees. If we connected another line, we can see there's one of our 60, 60, 60 triangles. So if this angle is 60 degrees, we know a side length adjacent to this angle, and we're trying to find both the hypotenuse and the opposite side. Let's find the hypotenuse first. Since I'm dealing with adjacent and hypotenuse, the trig function I want to use is cosine. Cosine of some angle equals the adjacent divided by the hypotenuse. In this case, that means the cosine of 60 degrees equals 2.15 divided by x. Since x is in the denominator, let's multiply it on both sides. X times the cosine of 60. Actually, cosine of 60 degrees is just 1/2. So x times 1/2 equals 2.15. At this point, we can just multiply both sides by 2, and we end up with side length x, or the hypotenuse, is 4.30. X is 4.30 centimeters. Now let's find side length y. For side length y, that's the opposite side from that 60 degrees. And then we also know the adjacent. We could use the hypotenuse as well, but let's stick with opposite and adjacent. Opposite and adjacent means I'm going to use tan function. The tangent of 60 degrees equals the opposite side, which is y, divided by the adjacent side, which is 2.15. Multiply both sides by 2.15 to solve, and that's something I'm going to enter in my calculator. The distance y is 3.7239. It goes on from there. I should probably round this to 2 decimal places. So my answer would be that the distance between two faces is 3.72 centimeters. Thank you.